Now we're going to use the magnitude of r prime of t cross r double prime of t divided by r prime of t cubed to find the curvature for the curve given by the vector function r of t is equal to ti plus t squared j plus e to the tk. Well, I said we. You know what's happening, don't you? Go ahead, pause the video, come back when you're done. I hope that went well for you. I personally like to gather my pieces, so I'll find r prime and then r double prime, and while I'm at it, the magnitude of r prime, and then put everything together when I'm done. R prime is I plus 2tj plus e to the tk. R double prime is then 2j plus e to the tk. The magnitude of r prime is going to be 1 plus the quantity of 2t squared, so 4t squared, plus e to the t squared, so e to the 2t. Crossing r prime with r double prime, we ultimately get 2t e to the t minus 2e to the ti minus e to the tj plus 2k. The magnitude of that cross product there is going to be, I factored out the e to the t, so a square root of e to the 2t times the quantity of 4t squared minus 8t plus 4, all of that is from the I component, plus 1, that's from the j component, and quantity, right, so that's all the e to the 2t applies to, then 2 squared, so plus 4, still inside the square root. Making that our numerator with the denominator of r prime cubed, we get the curvature kappa of t is equal to the square root of e to the 2t times the quantity of 4e to the t minus 8t plus 5, that plus 4 still inside the square root, all over the quantity of 1 plus 4t squared plus e to the 2t, whole thing to the 3/2 power there in the denominator. That may have seemed pretty bad, and it kind of was. But I'd like for you to imagine just for a moment what it would be like using the other formula we've seen.